Hello, your assignment for today is actually just that front page of worksheet on limits that we have in our packet. And it actually should be a reminder of what we've already done in the past on one of our block days. And so therefore I thought I would just go find some extra problems online, print them out, and show you how to do them. So ignore that this is calculus. We're actually looking at this from the pre-calc perspective. And the first problem says to use the graph provided to find the answers to the following questions. So, input output. F of 0 is what you get out from the function when you plug in 0. So looking at 0 as an input, notice there are no outputs at 0. There are no outputs at all. Like if there's any closed dots, that would be an output, but this one does not have any outputs. That's a does not exist. F of 2 would be the output from the graph when you stick in the number 2, and from right here we can see when we stick in 2, the y value, the output is 0. F of 3, what do you get when you stick in 3? Well, you don't get 1 because that's an open dot. You don't get 2 because it's an open dot. There's our actual closed dot. So that's what gives you 3. So that's how we interpret just functional values. They can be non-existent. They can be values that the graph looks like it's showing. And then there can be these weird ones. You're always looking for the closed dot. The second set of problems here is the limit as x approaches 0 from the left. So here is 0 as an x-coordinate, and as we approach 0 from the left, it means that I'm on this part of the graph, which is flying down towards an output of negative infinity. So that would be the limit as x approaches 0 from the left. The limit as as you approach 0 from the right gets really, really close to the output of 2. Since those are different, that means the limit as x approaches 0 in general is ambiguous, right? From the left, I can see negative infinity. From the right, it's getting close to 2. So this is a does not exist because there is no unambiguous value we can give to the limit as x approaches 0. Okay, how about approaching 3 from the right? So here's 3, and as I approach from the right, I can see that my outputs are getting close to 2. As I approach 3 overall, if I look at it from the right, I'm getting close to 2. From the left, it's getting close to 1. So this would also be a does not exist because it is not indicating that I'm approaching a fixed value, right? On this side, it's 2. On this side, it's 1. And then finally, the limit as x approaches negative infinity far to the left would be going down this part of the graph. And that seems to be approaching this horizontal asymptote that is located at 1. So that's how we interpret graphical limits. Let's try another set of values down here. Use this graph to answer the questions. F of 0, well, the output at 0 is 0. F of 2 is hitting an asymptote, and there are no closed dots on that asymptote, so we'd say this one is a does not exist. And F of 3, well, 1, 2, 3, again it looks like the output is 0. So those are the outputs of the function. Next, limit as you approach negative 1. Notice there's no left or right side indicator, so this is overall negative 1. From the left, positive infinity. From the right, negative infinity. Those are different, so that's a does not exist. X approaches 0. If I approach 0, I can see that as I approach x equals 0, from the left, the outputs are getting close to 0. As I approach x equals 0 from the right, the outputs of the function are also getting close to 0. So in that case, it's unambiguous. We can give it the value of 0. And then as we approach 2, but from the right-hand side, so this is the right-hand side, as I approach 2 from the right-hand side, I can see that the graph is flying down towards negative infinity, so that becomes a negative infinity. Again, as far as end behavior, this one asks for the limit as x approaches infinity, and if I look far to the right, I can see on the graph that my outputs are approaching the value of positive 1. Okay, so with that short video, that's all we're going to be doing today is just reviewing how to interpret graphs with limits. So if you need extra practice, don't forget to go back to block day number 1 and do a whole bunch of those graphical problems, but see if you can do our problems today.